This question is about electromagnetic waves, abbreviation EM waves. The graph shows how the intensity of electromagnetic radiation emitted from a distant star varies with wavelength. In which region of the electromagnetic spectrum is the radiation of greatest intensity? Options are infrared, visible light, ultraviolet, or X-ray. This line indicates the greatest intensity is when the peak of this wave is at 150. 150 nanometer in terms of the power of 10 is 150 times the multiplier for nano is 10 to the minus 9. And if I want to simplify, I can, using scientific notation here, for 150 will be 1.5 times 10 to positive 2 times 10 to negative 9. That gives us 1.5 times 10 to the minus 7 meter. Now, with this information, 10 to the power of a negative exponent, we can identify which region is this peak. Before moving forward with this problem, I want to ask you to memorize this. The wavelength of light goes from 4 to the 10 to the minus 7 meter up to 7 to the 10 minus 7 meter. One way that you can memorize is this. We work 4 to 7 days a week. This range corresponds to the color of light. Roy G. Biv. So all colors of light are at this range, 10 to the minus 7. So in this case, red is 4 times 10 to the minus 7. And the other extreme is the violet, which is 7 times 10 to the minus 7. If a problem asks to identify the color of light, then you have to work with this range from 4 to 7. But in this particular case, the visible light is one of the options, not its colors. This last note, in terms of the EM spectrum, use 10 to the negative power to identify the wavelength of the type of the EM wave. So let's start with visible light. So visible light goes from red to violet. So the type of the wave that go before the visible light is infrared. Infra is a prefix that means below. So this region here, infrared, is below red. Now let's look what happened after visible light. So now the last color for the visible light is violet. So the type of wave that goes after violet is ultraviolet. Now we have here ultraviolet and the visible light being 10 to the minus 7. So we can kind of work with the exponents for infrared minus 6 and for ultraviolet minus 8. Now going this direction, the next one will be X-ray. And X-ray is in the range of 10 to the minus 10. Now, to answer this question, because the peak of this intensity is right here on 150 nanometer, so corresponds to 1.5 times 10 to the minus 7 meter, which corresponds to the region of the visible light. So the answer is visible light.